walk you through a multiple regression that was done on a survey of Hamilton Holt School students back in 2012. And the survey, we're basically looking to get information and trying to understand what kinds of programs students were interested in, why they came to the Holt School, a variety of things. So for the purposes of this demonstration, though, we're going to look at the effect of different variables on overall satisfaction with Holt School education. So let's start by taking a look at the survey itself, and I'm going to cruise through this pretty quickly. The survey was actually delivered electronically. This is the PDF printout of the survey, and you can see basic demographic information was included in it. Things like biological sex, age, how many credit hours are folks completing this semester, ethnicity, which we're not going to analyze here, but I have looked at and didn't really predict much of anything in terms of satisfaction. The major that the person's in, did they transfer to Rollins? And then this page covers a variety of variables that are of a lot of interest. And basically we took a look at things that we knew resonated with Hamilton Holt School students and asked the question, when you think about the reasons why you chose Rollins College and the Hamilton Holt School for your undergraduate education, which factors come to mind? Rate each factor below in terms of its importance in your decision making. So things you would expect people would think about coming to Rollins: small class sizes, evening classes, flexibility of class scheduling, research opportunities, and so forth. Location of Winter Park, tuition assistance, parking, etc. So there's a whole bunch of these, and these are all going to be translated into variables and data in SPSS. We also asked them about challenges to completing their education and rating each of these challenges, like family issues, commuting issues, work schedule, and so forth, in terms of their ability to graduate. And one of the last questions was then, how satisfied were they with their Hamilton Holt School education? So let's start by looking at the SPSS file. And over here, this is the variable view. So you have the variables. I've already put in whether these are numeric or string variables. I put in whether these are scale, nominal. This is the scale of measurement is included on here as well. So all of the labels, all the values are already included. I go to data view, and you can see all of the data. This is actually a pretty big table with a lot of data. I have a total of 91 responses. Not all of them will be used in the analysis because there's some missing data in here, and when there's missing data, SPSS just ignores the case. And you can tell when the data is missing because essentially a period will be inserted into the cell that indicates there's no data there. Okay, so let's do the regression. We'll say regression linear. And we got to find our dependent variable. This is really the outcome variable. This is what we're trying to predict. And overall satisfaction, that's the variable we're trying to explain variance in. So what variables might be related to overall satisfaction? And so I'm going to put in a whole bunch of variables here. So we have year in school, sex, age, work status, credit hours. I'll put those in. I'm going to skip over ethnicity. I'm going to skip over the majors because nothing in the majors actually panned out when I was doing some of these analyses earlier as well. And let's go for these variables that were included on that big page we were looking at just a second ago. We'll move all of those over. And then we'll also move all of the challenges over that we think might be related. And I'm going to get rid of one of those. There's one here called lack of satisfaction challenge. The reason I'm getting rid of it is because that refers to whether somebody thinks they may not graduate just because they're not satisfied with their education at Holt School. That's really not different than our dependent variable, which is overall satisfaction. So we don't want a predictor variable that looks a whole lot like our dependent variable. Okay, so we're going to do that. I go under statistics. Model fit refers to the analysis of variance that will be computed as part of the regression analysis, and essentially we're looking to see if we get a statistically significant F ratio. And what that means is that the regression fits the data, the equation fits the data in a way that is greater than what we would expect by chance. We're also going to put R-squared change because we're going to be doing a stepwise regression and inputting variables one after another. We want to see how much variance is accounted for by each additional significant variable. We'll have descriptive statistics. I'm going to skip part and partial correlations and collinearity, diagnostics, and some of these other things that I would normally run just to keep this simple. So I say continue, and I'm going to skip also some of these plots and some other options that are available. Really, I'm just trying to give you the basics of how to do the regression and understand it. And I'm going to use a stepwise method for entering the independent variables, the predictors, into the equation. Okay, so what does that mean? What that means is we have a dependent variable, overall satisfaction, that we're trying to predict variation in. And each predictor, when it's entered into the equation, what SPSS is going to do is it's going to say, okay, I'm going to find the predictor variable that has the largest correlation with the dependent variable. And that's going to be the first variable that goes into the regression equation. And then we'll check to see if that is a statistically significant predictor. Okay, that variable is going to effectively account for a certain amount of, or proportion of, variance in the dependent variable. And only that variable can account for it. So the residual that's left over, what's left to predict then in the regression equation, is all the variation that our first predictor variable did not predict. So what that means is the order in which the predictor variables are entered is important. That first predictor is going to account for the most variance in the dependent variable, and then the second predictor and the third variable, the third predictor will account for less and less variance in the dependent variable or outcome variable. So our hope is that with each additional predictor we get a significantly greater amount of variance accounted for, right? But that's not always the case. Sometimes you have just one variable that accounts significantly for variation in the outcome variable. Sometimes no variables account for it. So, but that's what we're going to do, is a stepwise approach to the problem. So we're all set to go. We're going to run the regression, and you'll kind of see how this works once I get the output up. Okay, so here's the descriptive statistics, and we have all of these variables, their means and standard deviations. One thing to notice right away is that overall satisfaction has a very high mean. This is a scale from 1 to 5 with a standard deviation of 0.72, so that's not a huge standard deviation. What this is telling us is that most whole students are pretty satisfied with their education. So that's good news for the whole school. It's not great news for the regression, though, because what we may have here is a restricted range, meaning that most students are answering or giving 4s and 5s to this item, which means there's not a lot of variation in it. So there's really not going to be a ton of variance to be accounted for by any particular variable, and that could compromise the overall regression equation. So this is the problem of restricted range. Okay, so there's all our other variables. There's a big old correlation matrix, and that's a big table. I'm not going to show you the whole thing, but you can see just how big that is because there's so many variables that are computed to correlate with one another. And so here's what we end up with. We end up with a model in which the dependent variable is overall satisfaction. And in the first try at it, the first variable that was imputed as a predictor was quality of in-class experiences. The second variable that was entered was liberal arts curriculum. So when we gave the survey to folks and we asked them, why did you come to Rollins? The variable, or the question that they answered, which then created the variable quality of in-class experience, correlated very high with someone's current overall satisfaction. Okay. The item involving, well, I came here for liberal arts curriculum, that also correlated very high with overall satisfaction. So when we go down to the model summary, what we find is R for Model 1, which is just quality of in-class experience. Okay, so you can look down here, predictors. There's A in superscript. There's the A. Predictors, quality in-class experiences, so just one variable that we're looking at in terms of predicting satisfaction. It had a R, or correlation, of 0.538. We square that to get R squared of 0.289. The adjusted R square, which is what we pay attention to, is 0.277. Adjusted R square accounts for the sample size, so it basically is a better estimate of population parameters from the sample because it takes into account when you have a small sample. So if your sample is not huge, like we have, I don't know, somewhere around 80, 90 subjects here, you'll actually see the R square decrease just a little bit to make it a more accurate estimate of the population parameters. Okay, let's go down then to Model 2, because in the stepwise regression, what happened then was that the next highest correlating variable was entered into the regression. Okay, this R is now referred to as a multiple R because we have more than one variable correlating with satisfaction, and it is at 0.579. The square of that is R square, which is the proportion of variance explained or mirrored in the dependent variable by both of these variables together. So when you see 0.336, the way you can interpret that is to say 33.6% of the score variation in the satisfaction scores was accounted for or mirrored by the ratings for quality of in-class experiences and liberal arts curriculum. The adjusted R is 0.314, or 31.4% once we take into account sample size. Okay, so the good news is we have a statistically significant model here. In other words, the regression is accounting for more variance in the dependent variable than we would expect by chance or measurement error. The bad news is that it's not accounting for a ton of variance. It's only 31.4%. And that means that roughly 69% of the variation in satisfaction is not accounted for by these two variables. And that's a lot of unknown variation. Okay, the actual model fit here in the ANOVA shows the regression, residual, and total. What you really need to pay attention to here is just the F ratio and the significance level. So here you have superscript B, which shows that for Model 1 we're looking at just at quality of in-class experience, one predictor variable. That was a statistically significant model. Model 2 was also statistically significant, right? But we're going to prefer Model 2, and the reason we're going to prefer Model 2 is because that adjusted R square is actually higher than Model 1. In other words, more of the variance in the dependent variable is accounted for in Model 2 than in Model 1. Okay, then we come down to our coefficients. Let's just focus on Model 2 now. And what you'll see under coefficients is unstandardized coefficients and standardized coefficients. So in unstandardized coefficients, we are staying within the unit of our original measures and within those metrics. So the way to interpret this is that for every 1 unit change in quality of in-class experience, as being an important thing for a student, we see a 0.467 change in overall satisfaction. So the more that a student said, hey, the quality of that in-class experience was important to me, we then tended to see an increase in overall satisfaction. So we could say the same about a liberal arts curriculum. It's just a little weaker relationship, and that the way we interpret the unstandardized coefficient is to say, okay, for every unit change in the rating on liberal arts curriculum, we saw a 0.129 unit change in overall satisfaction. So less strong of a relationship. Now when you come to standardized coefficients, what's happening with beta, the standardized coefficient, is we now put the unstandardized coefficients into a common metric so that you can compare variables and their relationship to the dependent variable. Okay, now what's the metric? It's standard deviation units. So now the way we would interpret a standardized coefficient is to say, okay, for every unit change in quality of in-class experience, we see a 0.48 standard deviation change in overall satisfaction. For every unit of liberal arts curriculum score increases, we see a 0.22 standard deviation change in satisfaction scores. Okay? And then the rest of the printout here simply tells you whether or not this standardized change really is greater than what we would expect by chance. Okay, are we accounting for more variation than we would expect any variable to account for simply by chance or measurement error? And what we find is, yep, a significant value here, and then also for liberal arts curriculum, a significant value here. It's not p less than 0.001 as it is here, but it's still a significant difference. So both of these variables are accounting for significant amounts of unique variance in overall satisfaction, more than we would expect by chance or measurement error. We already knew that, by the way, from right here. The ANOVA basically tells us that the regression for Model 2, which included quality of in-class experiences in liberal arts curriculum, was statistically significant. What we get here is a little bit more detail. It breaks it down by the individual predictor variables and tells us how much or how significant each one is. Okay. Then there's a printout here of excluded variables, right? And there were a lot of them. These are variables that did not predict well. So that's basically the printout. There's a lot of other things that we could do with this. For example, if I wanted to, and this is a common thing that you might see, if I wanted to, I could go back to the regression menu, and I could add as a selection variable, say, I'll take this out as a predictor, I'll add sex as a selection variable, and basically I could see if the regression that I just came up with, the significant regression, held for both men and women. So I could select out only the males or only the females, and then run the regression again and see if in fact the regression held across men and women. I can tell you right now that one variable still held up, and that was our first one, which was the, let me see here, the quality of in-class experience was a significant predictor for both men and women. The one that did not hold up was the liberal arts experience, that liberal arts was important for women in terms of predicting their satisfaction, but not for men. So anyways, that's how you do a regression, and your book is going to have examples of how to actually write that up, so I'd encourage you to check with your book. And that's the end of the video.